In this video, I am going to discuss a procedure called Iterated Elimination of Dominated Strategies, or IEDS. Let us consider this simultaneous move game between player 1 and player 2. As you can see, there are two pure strategy Nash equilibriums in this game. One is BL, the other one is MR. Ideally, we would like to make only one prediction in a game. Now, since there are two pure strategy Nash equilibriums in the example that I showed you, therefore, in that game, we predict two possible outcomes, BL or MR. Hence, it is as if our prediction is not very sharp. We therefore use the concept of IEDS in order to narrow down our prediction. Let us begin with player 1. We want to find out if player 1 has either a dominated or a weakly dominated strategy. In order to determine this, we need to compare player 1's strategies pairwise. Let us compare T and M. Since player 1 is the owner of these two strategies, therefore we will do this comparison from the perspective of player 1. As you can see, if player 2 plays L, then player 1 prefers to respond by playing M instead of T. Likewise, if player 2 plays C, then player 1 again prefers M over T. And finally, if player 2 plays R, then also player 1 prefers M over T. So what we find out is that regardless of whatever strategy player 2 plays, player 1 always prefers M over T. Hence, T is a dominated strategy because it is dominated by M, and player 1 will never play T. We therefore eliminate T, since player 1 will never have any incentive of ever playing T, because whatever he gets by playing T, he gets something better by playing M. Hence we eliminate T, and this gives us the reduced payoff matrix that you see in your screen. Player 1 now has two surviving strategies, M and B. So let us compare M and B and check if either of them is a dominated or a weakly dominated strategy. If player 2 plays L, then player 1 gets 3 by playing M and 4 by playing B. Hence in this case, player 1 prefers B over M. Now if player 2 plays C, then player 1 gets 9 by playing M and only 5 by playing B. So in this case, player 1 actually prefers M over B. And finally, if player 2 plays R, then player 1 is indifferent between M and B. So what we find is that there is no clear consistent ranking between M and B. Sometimes player 1 prefers M over B, but there are cases where this preference reverses. Hence neither M nor B is a dominated strategy, and we cannot eliminate either of these rows. Let us do a similar exercise for player 2. Since player 2 has three possible strategies, therefore we need to compare them pairwise. So first, let us compare L and C. Now if player 1 plays M, then player 2 gets 5 by playing L and 4 by playing C. So if player 1 plays M, then player 2 prefers L over C. If player 1 plays B, then player 2 gets 10 by playing L and only 1 by playing C. So in this case also, player 2 prefers L over C. So in summary, player 2 always prefers L over C regardless of whatever strategy player 1 chooses, and hence C is an example of a dominated strategy, and hence we eliminate C. After eliminating C, we have the payoff matrix that looks like this. Now let us compare L and R and check if either of them is a dominated strategy. If player 1 plays M, then player 2 prefers R over L because he likes to get this 7 instead of the 5. And if player 1 plays B, then player 2 prefers L over R because he likes to get this 10 instead of the 8. So it turns out that in one situation, R is preferred over L, but in another situation, it's the other way around. There is no clear consistent ranking between L and R, and hence neither L nor R is an example of a dominated or a weakly dominated strategy. Hence, we cannot eliminate either L or R from this reduced matrix. So let us come back to player 1 again and check whether player 1 now has any dominated or a weakly dominated strategy in this reduced matrix. So we are going to compare M and B. If player 2 plays L, then player 1 prefers B over M. And if player 2 plays R, then player 1 is indifferent between B and M. So it turns out that player 1 never strictly prefers M over B. Sometimes he is indifferent, but in other situations, he actually prefers B over M. So since he never prefers M over B, therefore M is an example of a weakly dominated strategy, and player 1 will also never want to play a weakly dominated strategy. The reason is he has nothing to gain by playing M. Whatever he gets by playing M, he gets at least that much by playing B, and hence we can eliminate M as well. This leaves us with the reduced matrix that you see in your screen. This now has only one row but two columns. Now come back to player 2 again. Player 2 has two surviving strategies, L and R, but as you can see, he is going to prefer L over R in this reduced matrix. So it is as if in this reduced matrix, R is an example of a dominated strategy, and we can eliminate R as well. So once we eliminate R, it turns out that there is only one cell that survives this process of iterative elimination, and this is the cell BL. Now let us summarize our findings. We started with a simultaneous move game that had two pure strategy Nash equilibriums, BL and MR. It turns out that MR did not survive IEDS, but BL did. Hence BL is a more plausible prediction because it survives this tougher test of IEDS.